Hello YouTubers! In this video I would like to show you my latest design, which is a 6507 based single board computer. The purpose of this project was to build a simple, flexible and easy to use platform suitable for learning 6502 assembly language and interfacing with various peripherals. The system design allows for easy code uploading and convenient interfacing with external I/O devices. Let's go into the details of the mainboard components. This is the main component, which is of course the 6507 CPU. The reason I've chosen this model instead of a regular 6502 is very simple. I just happen to own one piece salvaged from a dead Atari 2600 console, and I didn't want a fully functional chip to be wasted. 6507 is internally the same as 6502, but with reduced pin count to 88 pins instead of 40. The most important pins that were omitted are A13 to A15 address lines, which limits the address space to 8 kilobytes, and interrupt request lines, NMI and IRQ, which is a sad thing as such CPU can't be used for learning interrupts. On the other hand, we have a CPU that is as simple as it can be, easy to understood and not too scary for absolute beginners. Next component is 2764 EEPROM memory for storing the monitor program. In my design, I'm only using 2 kilobytes of the whole 8 kilobytes EEPROM space, leaving A11 and A12 address line grounded. Next to the ROM chip, we have a static RAM chip. This is a standard type 6264 8 kilobyte device, of which I'm only using 4 kilobytes, leaving its A12 address line grounded. This larger chip here is a 16450 UART device used mainly for communication with the host PC. This chip is clocked directly by 1.8432 MHz crystal generator and uses baud rate of 38,400 bits per second. Another 40-pin device on the board is this 6526A complex interface device, commonly referred to as the CIA chip. This IC handles keyboard interface using its 8-bit port A and provides additional multipurpose 8-bit I/O port B connected to this gold pin socket here. The CIA chip also includes two 16-bit timers, one time of the day timer, and a serial communication circuitry with a form of flow control. Connectors for these additional features are also present on the board. In the left down corner of the board, we see address and control signals decoder consisting of two 7400 series ICs. In the upper part of the board, we have a few other small but necessary components. Here is the MAX1232 microprocessor monitor chip, which generates clean power on and push button reset signal for the CPU. The idea of using this part comes from Mike Naberezny's 6504 SBC project. Here is a crystal generator providing 1.8432 MHz clock signal, which is then divided by 2 in this 7474 flip-flop in order to produce less than 1 MHz phase 0 clock required by this particular CPU. Last small IC on the board is this 7400 NAND device used for interfacing the LCD display with the 6502 bus, exactly as described by Chris Ward in an article on 6502.org. Last feature that I would like to describe is this expansion connector here. It provides all necessary signals for building and testing of external peripherals of all sorts. Here we have power connector, data bus, reset signal, UART signals directly compatible with standard PL2303 USB to UART converter. Next, we have in this section 8 UART control signals, which can be used for flow control or with a little programming effort as general I/O pins. In the next section, we have 4 address lines, A0 to A3, enough for register selection in most interface chips. And in the last block, we have control signals, phase 2 and read-write signals directly from the CPU, and also read, write and additional chip select signal IO4 taken from the address and control signals decoder. Now we will power up the board and show some of the ROM monitor features. I will also load and execute a small example program. Now we can see the ROM monitor menu. I will use edit function to directly enter example code into the memory using hex keypad. I have printed a listing of an example program that will be continuously writing increasing binary number to the CIA port B. To see what's happening, I will connect LEDs with resistors to the port B of the CIA chip. Let's enter the code now. Okay, now we can use dump command to verify if the code was correctly typed in. Okay, now we can use jump function to execute the code. As you can see, the CPU is executing the program. Now I will download another example code, but this time I will use UART for this. We can use load command to get the code inside RAM memory and then jump command to execute it. But there is an easier way. If we reset the board while pressing the 1K, the ROM monitor will instantly enter into UART downloading mode with destination set to 0200 hex. After receiving the code, it will be immediately executed. Let's see. Thanks to this function, it is very easy to write 6502 code on the PC and immediately upload it to the target board. Okay, that's all I wanted to show you today. If you are interested in this project, I will provide a link in the description where you will find all the documentation, source code and project files. If you have any questions regarding the project, feel free to use comments section below. Thank you for watching.